Welcome to This Explainer. Okay, today we're going to do something absolutely fascinating. We are not just going to sit here and look at pretty space pictures, as cool as they are. No, we are going to literally decode the universe itself. We're going to dive right into the first principles of how the James Webb Space Telescope actually works, and exactly why it's completely changing everything we thought we knew about the cosmos. Let's get right into it.
So what actually becomes visible when a telescope is explicitly designed to see the universe's faintest, most stretched out light? Think about that for a second. Older telescopes, they showed us absolutely incredible things. But Webb was built from the ground up to capture a completely hidden reality, stuff that was literally invisible to us before now.
Which brings us to Section 1, the invisible infrared universe.
You see, trying to understand the whole entirety of space using only visible light, it's kind of like trying to understand a massive, sprawling city by only looking at its bright neon signs. If you do that, you'd completely miss all the houses, the dark roads, the underlying machinery that makes the city run, right? Well, infrared light is like finally being able to hear the deep, thumping bass tones of a song right through a thick cosmic wall when all those high notes just get blocked out. It completely reveals the hidden underlying structure of everything.
So to be super precise here, infrared light is basically longer wavelength light. And this usually comes from cooler objects out there or from light that has literally been stretched out over time by cosmic expansion. So Webb isn't just, some giant magnifying glass making things look a bit bigger. Not at all. It's an entirely different kind of detector. It's specifically tuned to catch these hidden, longer wavelengths of light that we couldn't see before.
Moving on to Section 2, reading stretched ancient light.
Okay, let's actually trace this journey, because it's wild. First off, a star emits light, right? But as that light travels across billions of light years, space itself is actively expanding. Think of it like taking a rubber band and drawing some dots on it. If you grab the ends and stretch that rubber band out, those dots physically move farther apart. Well, cosmic expansion does the exact same thing to light waves. It physically stretches them out over space and time. And as that light stretches, its wavelength shifts all the way down into the infrared spectrum. Older telescopes were honestly just like radios, tuned to the completely wrong station, trying and failing to pick up this signal. But Webb was built specifically for this exact stretched frequency.
Now, because light actually takes time to travel across the sheer vastness of space, seeing farther away physically means seeing earlier in time. Looking deep into the cosmos is honestly exactly like listening to an incredibly ancient voicemail. You aren't hearing that person right now in this exact moment. You're hearing a message from the deep past. Webb is literally reading messages written in light from the very dawn of time itself. How cool is that?
And there's another massive advantage to having infrared vision here. You see, in astronomy, dust is not just empty, annoying clutter. It's actually a major part of the story. Cosmic dust blocks visible light completely. It's pretty much like trying to look through a super fogged up kitchen window that hides whatever's cooking inside. But infrared light? It just passes right through all that dust, letting Webb sense the heat and all the incredible activity happening deep inside those clouds.
Okay, before we get to the really juicy discoveries, let's lock all this in with a core mental model. Reality on one side and what it actually means for us on the other. Light carries information, which means astronomy is just the act of reading messages. Faraway light gets stretched out, meaning distant objects shift into the infrared. Farther means earlier, so looking out is looking back in time. Sensitivity absolutely matters, so faint things need better light collection. And finally, dust hides visible details, but infrared uncovers them. Keep this mental model right in the front of your head, because it literally unlocks everything we're about to look at next.
All right, let's hit Section 3, the biggest discoveries connected.
So here is the very first massive shock that astronomers got. Webb looked way back to the early universe and found young galaxies that appeared way earlier and were vastly more developed than anyone expected. Honestly, before Webb, all the models based on older, weaker data just suggested the early universe was really sparse, kind of messy and slow. But finding mature galaxies this early, that means the universe organized its stars, its gas, and dark matter much faster than we ever thought possible. It's a total game changer.
And building right on top of that, Webb also found heavy elements way earlier than expected. Now, complexity doesn't just spontaneously appear out of nowhere, right? Detecting these heavy elements means early stars had already fully formed, lived out their entire lives, died, and then rapidly recycled all their materials back into the cosmos.
It absolutely proves that the early universe was incredibly dynamic, actively cooking up complex ingredients right from the very start. Now remember our rule about dust from earlier? Webb is actively using its infrared superpower to show a star formation that's completely hidden behind incredibly thick dust clouds. We are not just looking at some static, boring object here. We're observing a really active, messy, chaotic process. Webb peers directly into these dusty stellar nurseries, showing us exactly how matter collapses, heats up, and literally ignites into brand new stars and planetary systems in real time.
And the precision on this thing is so good that Webb actually acts like a cosmic chemical detective, reading the literal fingerprints of exoplanets. When starlight filters through an exoplanet's atmosphere, Webb can read the tiny modifications in that light to detect things like water vapor, methane, or even carbon dioxide. It can even tell us if a distant world is rocky or just a big gas giant. It's exactly like guessing all the ingredients of a complex recipe just by smelling the steam rising off a boiling pot. It's wild.
Bringing us to Section 4, our new cosmic history.
So all of this comes together into one beautiful, grand narrative. The early universe formed galaxies way sooner than expected. Then those galaxies made stars. Those stars created heavy elements, and those elements were rapidly recycled into dust, new stars, and eventually planets. Webb isn't just out there finding isolated random objects in the dark. It is revealing a highly connected, beautifully working system that is actively building itself through these continuous, massive cycles. So honestly, the next time someone asks you why this massive telescope actually matters, I want you to remember this quote. It gave us a new way to read the universe, and that changed what the universe is able to tell us. That hits the nail on the head. Webb is not just a bigger magnifying glass, folks. It is an entirely new receiver for the cosmos, finally allowing us to translate the faint, ancient, stretched-out light that was always out there, just waiting to be read.
As we wrap up this explainer today, I really want to leave you with one final provocative question to chew on. Now that we finally have the right tools to read the invisible, what future hidden signals will we decode next? I mean, the universe has literally been broadcasting its story for billions of years, and we are just now finally learning how to listen. Thank you so much for joining me to explore this today, and as always, stay curious.